All right, let's go through it. So we are testing tomorrow. We want to make sure we know what's going on today. Uh, to start off class, we did a Quizizz. So this is posted on Schwann Academy if you would like to go through it on your own, but we just did it. So let's go through our answers. For the most part, we were pretty good here, but let's double check. Okay, this Quizizz is mostly calculator type questions. You can do all of them with your calculator and know what's going on. The derivative of the function is given by f prime. How many points of inflection are on that graph? So a couple things I wanted you to do here. The first thing is being able to type in the equation. Okay. The second thing is looking at the window. It's from negative 2.5 to 2.5. So window negative 2.5 to 2.5. I want to make sure that's true. Okay. If I hit graph, I see this. And if you look at this, you really can see a lot of things, but not everything. Notice that it goes a little bit higher and lower. So you've got to be able to zoom in and out to see what you need. It's easier to see the middle when it's like this, but we want to see everything. So I'm going to go from negative 12 to 12. There's my graph. This is an F prime graph. What am I looking for on an F prime graph to find points of inflection? What am I looking for on an F prime graph to find points of inflection? Relative extrema. F prime has relative extrema as when you have points of inflection. So 1, 2, 3, 4. Those are the 4 spots, the places where the slope changes signs. That's all I'm looking for. The middle's not anything because it's not a max or min. It doesn't change signs. It goes negative and then more negative. Negative slope at least. Questions on the first one? Number 2. This is a graph of F prime. We're trying to figure out F. And so this is a question from an AP exam. So this is how they would ask it. F prime. F prime right here. This would be the place I'm looking at. What is happening with F prime there? F prime changes from negative to positive. If F prime changes from negative to positive, what is happening on F? There's a minimum. So F has a minimum. So I'm looking on my graph. Where does F have a minimum? Right around there. Oh, that one's got a minimum. That's a maximum. It's not B. That's nothing. That's nothing. It's got to be A because F prime or F has a minimum at that spot. Okay, there's other things you could look at. For example, here F prime is all positive here. If F prime is positive, that means F is increasing. You could look for other things like that as well. Questions on the graph. Number 3, the second derivative of the function is given by that thing right there on the interval from 0 to 5. I want to know when I'm concave down. So let's graph it. Alpha F1, because I want to type it in as a fraction. Make sure you are in radians. If you're in degrees, you're getting them all wrong. Cosine x over square root of x. And it asked us to do it on the window from 0 to 5. I've also done this problem earlier, and so I know I need my y min and max to be a little bit smaller. So we'll go from negative 3 to 3. We hit graph. This is an F double prime graph. If I'm doing F double prime and I want to know when I'm concave down, what is going to be true about F double prime when it's concave down? It's negative. So positive, positive, positive. Right there, it starts being negative until right there. So it looks like from about 1.5 to about 4.5. Okay, if this wasn't a multiple choice question, I would actually find the zeros. But here, I'm going to use my brain and say, hey, I'm not going to actually do that. There is the answer I want, 1.5 and 4.7. Questions on 3. So F double prime changes sign, or F double prime is negative. That's when I'm concave down. Next one. This is a velocity graph. This is velocity. I want to know, when am I moving backwards? What is going to be true about velocity if you're moving backwards? What needs to be true about velocity if you're moving backwards? Negative. It's D. It's the only one that's negative. Speeding up versus slowing down. What do I need to look at to decide if something is speeding up or slowing down? Same signs. What has to be the same signs? Yep. I want to figure out what V of 4 is and what A of 4 is. You want to compare the signs on velocity and acceleration. This is a graph of velocity. To find V of 4, we're going to plug 4 in. Okay, you take 4, you plug it into that, you get a negative number. Okay, to find a of 4. Well, first thing I would have to find is a of t. The derivative is negative 2t plus 2. So a at 4 would be negative. Velocity is negative. Acceleration is negative. What's going to be true about the particle? Speeding up. My velocity and acceleration have the same sign. I'm speeding up. Last one. They gave me a position equation. Now I want to talk about velocity. What do I need to do with a position equation to talk about velocity? Derivative. The derivative of 3. 3 is a constant, so it hangs out. The derivative sign is cosine. The derivative of 2 goes away. All I got to do is plug in pi. Cosine at pi. Here's a unit circle. There is pi. It's the ordered pair negative 1, 0. Cosine is the x value. My answer is negative 3. Questions there? Number 7, which one do you still need work on? Talk with your neighbor. A, B, C, or D. Which one of those 4 categories are you going to spend the most time on tonight? Talk to each other. As we look at this, A, B, C, or D, show me with your fingers. 1, 2, 3, or 4. Which one do you need the most work on still tonight? In here, it looks like 2 and 3, and maybe a couple 4s, but 2 and 3 were the main ones. Okay, so let's talk about this test going in tomorrow. Okay, derivatives using a calculator. Tomorrow's test, there are 9 multiple choice questions. 6 of them are non-calculator, 3 of them are calculator. The free response is non-calculator. So there are 3 multiple choice questions tomorrow where you can use your calculator. So if that's your worst thing, get better at it, but know that it's 3 questions. Okay, you're probably okay, but make sure that you are. Okay, particle motion. Again, I would say maybe at most there is going to be like 3 multiple choice questions, maybe a free response, but that's not been the main part. Okay, the 2 big things going in tomorrow is this and this. Those are the 2 things you got to be able to do. Okay, the first one, that's being able to take a derivative, set it equal to 0 and solve it, or when it's undefined and solve it. Put it on a sign chart, positive, negative, all that good stuff. We have not done a lot of this today. Okay, we're not going to do a lot of that today, but that is something we could do. And then graph stuff and doing justifications. Those are the 2 big ones. If you can't do this one tomorrow, you'll be very sad. Okay, you will be sad because it's over half the test is being good at that. Make sense there? Let me remind you about Schwann Academy. Some of you, it might have been a minute since you've been on there. Okay, here's Schwann Academy. We click on 3A. Here are the different sections. Okay, right here is Khan Academy Practice. If you click on Khan Academy Practice, this is going to break up the entire chapter into Khan Academy. This is why I made the website. Okay, I made this website because Khan Academy is really good. Okay, and I wanted a place to organize it. But here is the entire chapter broke up into the 4 sections we just described. Okay, hey, I'm not good at analyzing derivative equations. Then here are the different categories. You click on one. It takes a while to load. Know that. When you click on it, it's going to take like 25 seconds. Okay, that's a long time for me on the internet. But once it loads, it's going to get you, oh man. Let's act like it loaded. And I just wanted the second derivative test one. There it is. Okay, so this would pop up on your thing. Eventually, it would load. Okay, you would have questions like this. F of 2 is 3, F prime of 2 is 0, and F double prime is positive. So that would, you click on one, you go, check it. Oh, I'm wrong. Okay, but I did it quickly on purpose because of this. When you miss it, it then has a get help button. Click on the get help button. Then it will walk you through exactly what you're doing and then also give you a video. So it's going to give you step-by-step hint as to what you need to do. This is a great way to study tonight. You just told me what thing you're good at and what thing you're bad at. So now you can go back to here and utilize that to be better at it. Questions with that? Real quick. So I'm just going to go through some of the most missed questions on this other quizzes that I gave you. There's only a couple here that we need to look at, but 1, 11, and 12 will be the ones we look at. So let's look at those, and if you have anything else, I will do that as well. But number 1 here, this is an F graph. Okay, they said this is an f graph. What can you say about the value of d squared y over dx squared? What does that mean? The second derivative at the marked point. What is true? What am I looking for on an f graph to talk about the second derivative? Concavity. What is true about the concavity right there? It is concave up like a cup. And if it's concave up like a cup, it's positive. That's been one of the most missed questions of the day. Hopefully it's just a matter of getting used to those questions because we didn't have the same issues after that. But there's number 1. Next one we missed was number 11. Where's the point of inflection? This is an f double prime graph. If this is an f double prime graph, what needs to happen in order to have a point of inflection? It's got to change signs. F double prime changes signs. So right there, because it changes from positive to negative. And then right there, because it changes from negative to positive. F double prime changes signs at 0 and A. Yes, ma'am. You never said point of inflection on F, which is where I was confused. Did you say point of inflection? When there are point of inflections on F double prime? Yeah, gotcha. Yeah, they would be clearer than that. I wrote this question, so it was where does F have a point of inflection? Good thought. I understand on that. Number 12, they're giving you a couple tables of numbers, and they're asking when is the first derivative positive and the second derivative negative. So based off of this thing, first derivative, so f prime needs to be positive, and f double prime needs to be negative. What is true if f prime is positive? These are f tables, so what has to be true about f? Slope is positive, or in other words, f is increasing. F is increasing, F is increasing, F is decreasing because it's going from 16 to 12 to 9 to 7. It's not that one. Okay, so we've done that. It's either A or B. F double prime needs to be negative. What are we talking about if F double prime needs to be negative? Concave down. So when in doubt, graph it out. I'm going to do the most basic graph ever. 1, 2, 3, 4, 5, 6, 7. There's 2, 7. There's 3, 9. There's 4, 12. There's 5, 16. That's concave up. 2, 7, 3, 11, 4, 14, 5, 16. Concave down. It's increasing, but it's increasing by less and less each time, which means it's decelerating if you want to get fancy. The acceleration is negative there, okay, because it's not increasing at the same rate. Questions on that one? Any other of these questions that you would want me to walk through because you weren't sure about? All right, I'll come back again at the end if you have any more. Keep going. So looking at this review, 23, 24, 25, those were the last 3 that we kind of struggled with. We are looking at position. What is the speed when the acceleration is 0? If I want to figure out when the acceleration is 0, I got to find the second derivative. So I'm going to go ahead and find velocity. Minus 12t, that's velocity. And I'm going to find acceleration. The acceleration will be 6t minus 12. I want to know when acceleration is 0. So I'm going to take that derivative and set it equal to 0. I'm going to solve it. I'm going to divide. T is 2. That's the time. That's not the answer. The question is, what is the speed? How am I going to figure out what the speed is? What does speed mean? It is the absolute value of velocity. That's what speed means. Not talking about speeding up, slowing down, but just speed in general is the absolute value of velocity. And so I'm going to find v of 2. So it's 3 times 2 squared minus 12 times 2. 2 squared is 4 times 3 is 12 minus 24. I get negative 12, but we are talking about speed. And if we're talking about speed, it is the absolute value of that. It is a positive 12. Questions on 23. 24, it says, which of the following graphs appears to show the derivative of this function? So it's super blurry, but we can see it here. The slope is positive. So at the beginning, there it goes. At the beginning, the slope is positive, and so I want my graph to be positive. So it is not A or B, because here at the beginning, the graph is negative. Those do not work. Okay, so it's one of those two. Here, the slope is negative. Would you say the slope is constant? No, it's bent. Okay, so I don't want it to necessarily be a constant slope. It's not going to be D because D has a constant slope. Okay, the slope is negative there. It's got to be that one. Is that right? Okay, that just looks weird to me for a second. Oh, okay, my fault, my fault. I was thinking that this side, why did it go positive? It went positive because over there, the positive slope. My fault. I was looking at it funky. It is C. Okay, so looking through that aspect is what we need. Here at the end, the slope is negative, and so my graph has to be below. Okay, last one. Use the sign chart to help understand what is going on. We are trying to figure out what's going on. So a local minimum, local maximum, and then absolute maximum. So right here could be a minimum at -2 because it changes from positive to negative. So that could be a local minimum. None of those questions are asking that. So, all right, so that didn't help us. At 4, we could have a local maximum. Okay, it's a local maximum because I'm changing from positive to negative. No, neither of those are true. These are not local maxes and mins at endpoints. Endpoints are not considered local maxes and mins. They can only be absolute maxes and mins. A local max or min means I have to change signs. Okay, so do I have an absolute minimum at -2? At -2, I get 0. That is the lowest value out of any of these. And so 0 is going to be, or there is going to be an absolute minimum at 0, or at -2. That's a weird question. That is not one I'm super concerned about yet. You can use your brain and figure it out, but that is something I'm going to worry about more in the next chapter. Yes, ma'am. Okay. Well, it doesn't make any sense to be that. I don't like the word local then. It might be true that it's that. I don't like that they threw the word local in there because that's incorrect if that's how it's said. This would be a maximum at -10, but I wouldn't refer to it as a local max. Other questions? Any of these other ones you want me to look at? Good enough. Be ready for tomorrow. Make sure you've gone through Khan Academy and you know what your stuff is.